This is Calc BC, and it's Objective 4 for Unit 6, and we're dealing with even powers of sines and cosines. A little bit tougher to deal with than the odd powers for the trig functions, but anyway, it's useful for us to remind ourselves about the half-angle formulas. Sine squared theta is 1 minus cosine 2 theta over 2, and cosine squared theta equals 1 plus cosine 2 theta all over 2. These will definitely come into play. Now, we have experienced some of this already before, earlier in the year. It's just that a little bit more involved with some of these. Okay, so now the first one here, integrating sine squared 2t with respect to t. Now, technically, I mean, we did something like this earlier in the year anyway, because particularly since it's just sine squared. Okay, so because of that, sine squared theta, we want to go ahead and do our substitution here. And so I've got 1 minus cosine. Okay, now twice theta. Notice the relationship in the angles here. So sine squared theta, and then it's cosine 2 theta. So you have to double the angle as you're going to this half angle form. So double 2t, and I get 4t over 2 with respect to t. Okay, now that's the key right here, is making that substitution. Now, this is the way I have the formula memorized. Maybe you can just go ahead and go straight to the fact that there is a GCF of 1/2 and bring it out in front. So you might bypass this first step that I just did right there. And so it's 1 minus cosine 4t with respect to t. And so I have 1/2, and I've got t, and then cosine 4t, negative cosine 4t. So that would be negative sine of 4t. The angle's not going to change, but the derivative of the guts right there would be 4. I didn't have a 4 there, so I need a 1/4. Okay, plus c. It's an indefinite integral, so don't forget that. And if I go ahead and distribute the 1/2, I've got 1/2 t, 4t over 2, minus 1/8 sine of 4t, plus 1/2 times c is still a constant. Okay, and so there's that one. Like I said, this problem right here really could have been something that we did earlier in the semester. Now, moving on to problem number 2. Now, this one, not so much. Okay, so it's kind of some similarities to what we were doing in this last set of notes for the 6.3. I'm not peeling off one of them, but we do have an even power here, so cosine to the 6th. And so what I can do is I can break that down into cosine squared cubed Okay, now why is that helpful to us? Because now once I get it to be cosine squared x, I can change that using a Pythagorean identity. And so cosine squared is 1 minus sine squared. Okay, now I know that some of you are saying, well, why didn't you just change the denominator? Typically, we'd like to have the denominator. If there's a single thing in the denominator, there's definitely an advantage of having a single thing in the denominator, and we can perhaps split up the fraction into more than one fraction when there's a single thing in the denominator. And if you have more than one term in the denominator, then you start running into trouble. So if you're going to get more than one term, get it in the numerator as opposed to the denominator. Let's see, I need my dx right there. Okay, now the sad news is that we actually have to multiply out the numerator. So now quantity cubed, remember quantity cubed means that you're multiplying it by itself 3 times. Now, yes, there is a shortcut if you happen to remember Pascal's triangle, so quantity cubed, and so we're reminding ourselves that 1, 3, 3, 1, okay, and so we've got 1, and remind yourself what the a and the b are. So the a is the 1 and the b is the negative sine squared x. So 1a cubed, okay, so 1 cubed, so 1 plus, and then I've got 3, and then I've got a squared times b, so negative sine squared x, plus 3 times 1 to the first times the negative sine squared x squared, plus 1 times 1 to the 0 times the b cubed. And I guess I didn't note all of it out there, but this was the one out here was 1 times 1 cubed times negative sine squared x to the 0 power. Okay, all over sine squared x with respect to x. Okay, so now if I clean up that numerator, I've got 1, I've got minus 3 sine squared x, I've got plus 3 sine to the 4th x, and then I've got minus sine to the 6th x, all over sine squared x with respect to x. Okay, now as I was already mentioning, because I have the single thing in the denominator, I can actually break up this fraction so that I have 1 over sine squared x minus 3 sine squared x over sine squared x plus 3 sine to the 4th x over sine squared x minus sine to the 6th x over sine squared x, and so on. So if I do that, we get 1 over sine squared x, which 1 over sine squared x is cosecant squared x. I get negative 3 sine squared x over sine squared x, which is just negative 3. I get positive 3 sine to the 4th x over sine squared x, which is positive 3 sine squared x. And then I get minus sine to the 6th x over sine squared x, which is minus sine to the 4th x with respect to x. Okay, so, well, let's see. Cosecant squared, isn't cosecant squared simply the derivative of negative cotangent x? So, integrating term by term here, we've got negative cotangent x. I've got minus 3x, okay? Now, plus 3 sine squared x. Okay, that's an even power, okay? Well, guess what? It's and I'm gonna break this up here. I've got positive 3 here on the outside, and half angle formula substitution. Okay, so I'm remembering I've got a GCF of 1/2, so I'm going to go ahead and put a 1/2 out in front, and 1 minus cosine of twice the angle. The angle is x, so twice the angle is 2x dx. Okay. Now, integrating term by term, so I've got minus, and then I've got sine to the 4th. Okay, what the heck am I doing with sine to the 4th? Well, sine to the 4th is sine squared x squared. Okay, so let me write that down here somewhere. Sine squared x squared. Now, you might be thinking, okay, well, let's go ahead and make a substitution of 1 minus cosine squared x. You could, but it's not really helpful. It doesn't really help us so much because cosine squared, you'd still have to do a half angle formula substitution. So really, we're just going to go ahead and do the sine squared x, and we're going to go ahead and do the half angle formula substitution for the sine squared x. And so I have 1 minus cosine of twice the angle all over 2 quantity squared dx. Okay, so we've got negative cotangent x minus 3x plus, okay, so I've got 3 halves, and I've got x and minus 1/2 sine 2x plus a constant, but we just need to remember the plus c at the end somewhere. If you're thinking you're worried that it might not, you might not remember it, go ahead and do the plus c right now. Minus, okay, now this one, sorry, but yes, we need to actually square it. And how do you square something like that? You multiply by itself. So we have a 1/4, so minus 1/4 integral, and then I would have 1 minus 2 cosine 2x plus cosine squared 2x with respect to x. Okay, so negative cotangent x minus 3x plus, okay, distribute the 3 halves. And so I've got plus 3 halves x minus 3/4 sine of 2x. By the way, it's very important to keep track and make sure that your 2's look like 2's and your squareds look like it's an exponent. And 3 halves times a constant is still a constant, okay. Okay, now I've got negative 1/4 times, okay. So I would have x, and let's see, negative 2 cosine 2x. So that's going to be, now I can see the derivative of the guts right there, the 2. So negative sine 2x. So the derivative of negative sine 2x is negative 2 cosine 2x. So that's nice right there. Okay. Plus, and I got to do one more half angle formula substitution here. Okay, so cosine squared 2x, so there's going to be a GCF of 1/2, and 1 plus cosine of twice that angle, so twice 2x is 4x with respect to x. Okay, distributing the negative 1/4. So we've got negative cotangent x minus 3x plus 3 halves x. Those are like terms, obviously we need to combine those. Minus 3/4 sine 2x plus c minus 1/4 x plus 1/4 sine 2x minus 1/8 times, okay, so I would be getting x, and I would also be getting plus 1/4 sine 4x, and we don't need a plus c because we already did the plus c. If you didn't do the plus c earlier, make sure you remember to do the plus c here at the end. Okay, so now we've got negative cotangent x. Okay, minus 3x plus 3 halves x. So that's negative 3 halves x. Minus 3/4 sine 2x plus 1/4 sine 2x. So that's negative 1/2 sine 2x. plus c minus 1/4 x. Obviously, I can combine that into the negative 3/2 x, but I also have a negative 1/8 x, and I have a negative 1/32 sine 4x. Okay, I think we're going to finish it all here on this term. So, negative cotangent x. Negative 1/4 x minus 1/8 x. So that's negative 3/8 x. Negative 3/8 x with negative 3/2 x. Okay, so let's see, that would be negative 12/8 x minus 3/8 x, so negative 15/8 x. The signs are not like terms, so I've got negative 1/2 sine of 2x, negative 1/32 sine of 4x, and don't forget the plus c. Okay, so that's the second one. Finally, third problem. By the way, if we did the derivative of this, we would get back to this original problem, cosine 6 to the 6th x over sine squared x. Okay, finally, this last problem here. Sorry, it's not number 5. Number 3. So the integral from 0 to 2 pi of the square root of 1 plus cosine x over 4 with respect to x. Okay, so if we start looking at that, if you're thinking like a u substitution, if u is 1 plus cosine of x over 4, well, the derivative of the guts would be negative sine something, and that's obviously not there. And so we're looking at it and we're just going, oh my goodness, what can we do? Well, this 1 plus cosine of something is kind of reminding me of the half angle formula stuff. It's pretty close to this cosine squared, 1 plus cosine of an angle. All it needs is the over 2. Okay, so I think I want to fix it so that I have over 2. Okay, now I just adjusted the problem, didn't I? So what I need to do is I need to balance out what I just did. So if I divide by 2, I just have to balance it out with a multiply by 2. So right now I have effectively multiplied by 1, and so it's okay. This is good. I don't have to do anything else. I've effectively multiplied by 1, and I'm still doing the same problem that I did before. But what's nice now is the 1 plus cosine of that angle over 2, I can substitute using my half angle formula. Well, what about the 2 out here? Well, that's just root 2. And so I can bring that out in front. So I have root 2, 0 to 2 pi, square root. And so now the 1 plus cosine of the angle over 2. Now this time I'm going the other direction. And so I'm going from the 1 plus cosine 2 theta over 2 to the cosine squared theta. So I'm going from 2 theta to 1 theta. And so we have to keep track of which way we're going here. So now there's my root 2 out front. So 1 plus cosine of 2 theta over 2. This becomes cosine squared. Okay, so this is 2 theta, and I want to change it to just theta. Okay, so if I multiply by 1/2, dx. You know what? That's not what it's supposed to be. I said multiply by 1/2, right? What's 1/2 times x over 4? X over 8. I said the right thing, I just did not do the right thing, so good thing that I caught that. Okay, so now what's the square root of cosine squared of an angle? Well, it's the absolute value of cosine of the angle. Okay, so this is root 2, 0 to 2 pi, absolute value, cosine of the angle, dx. Okay, now, from 0 to 2 pi, what do I know about cosine of x over 8? Well, cosine x over 8, what is the length of the period? How do we calculate the length of the period for sine or cosine? So the period length is 2 pi over b. So 2 pi over, now what's the coefficient of x here? It's 1/8. So 2 pi over 1/8, that's 16 pi. So the period length for cosine of x over 8 is 16 pi. So if you're thinking about it just real quickly, and we should all have a picture of cosine in our mind, okay, that's 16 pi, which means that this right here is 8 pi, which means that this right here is 4 pi, okay? And so what do I know about cosine of x over 8 from 0 to 2 pi based on my little sketch right here? It's going to be completely above the x-axis, and so therefore it's going to be positive values. I can drop the absolute value then. Okay, so we have root 2, definite integral 0 to 2 pi, and now I can just drop the absolute value. So I've got cosine of x over 8 dx. So I have root 2 times, okay, so cosine is the derivative of sine of whatever the angle is. Now the derivative of the guts would be 1/8, so I need an 8 to balance that out. Okay, so I'm going to bring the 8 out front, so 8 root 2. Okay, so sine of x over 8. So 2 pi over 8. 2 pi over 8 is pi over 4. Sine of pi over 4 is 1 over root 2. And if I plug in a 0, sine of 0 is 0. And so we get 8, which is pretty amazing.